Okay, so we're given the slope-intercept form, y equal mx plus b, and remember that you can think of this graphically as the two parts is I start with y equal mx, and I'll draw it with a positive slope, so there's x and there's y, and I've got a positive slope. And then we add b to it, and so plus b, and again if b is positive it raises that thing up, and so there's y equal mx plus b, and it goes through the b like that. Okay, so we have this form y equal mx plus b, and now again, you could be given some information, and maybe you're given the slope and a point. Now, some of you may remember that there is this thing called a point slope form. We're not going to worry about that yet. That's coming in another video, but we can still deal with this idea. We can evaluate this, try to find m and b if we're given the slope and a point. Now, so, well, okay, I'm told here's my info, and somebody just flat out tells me the slope is 3 and the line contains the point maybe 2, 8. Okay, so I've been given that information. Well, what I know right away is using the point slope form, since I know I have a straight line and I know the slope is 3, I know that actually I have this, y equal 3x plus b, because the slope is 3. So it has to be that. Now the other thing I know is this point, but the key is this algebra here has to work for every point on the line. If a point somewhere in the Cartesian coordinate system does not make this equation work, it can't be on the line. And so we're going to use that. We're going to use 2, 8 is on the line. So I'm going to use that information, and that means that if I have 8 for y and 2 for x, when I add b, I should be able to get 3 times 2 plus b is equal to 8. It should work. And so, well, 8 is equal to 6 plus b. Now I do a little algebra, and this is where the algebraic language is just so nice, is that I can do this idea of subtracting 6 from both sides, and when I do that I get an equivalent equation, equivalent in the sense that the answer is the same answer as far as what I don't know yet, this b, and so I get that b equals 2. Okay, and thus y equals 3x plus 2. Okay, so if I'm given a point and a slope, I can do it that way. And notice that actually with a y-intercept, it really is working the same way. It's just quicker with the y-intercept, where I can just say, oh, b is whatever, because notice if I tell you the slope is 3 and y-intercept is 2, actually we've done a shorthand notation. because really what we're saying is the slope is 3 and we have the point 0, 2. Now, technically, when you say y-intercept, you really should call it 0, 2, but we don't. It's a shorthand thing, it's a contraction, it's slang. Okay, every language has its slang, and math is no different. In this case, we often just say the y-intercept is 2, but you know, really technically, if the y-intercept is a point, which it is, then it needs an x and a y coordinate, so it's 0, 2. So when we say the slope is 3 and we have a y-intercept of 2, we're really making this statement that the slope is 3 and the line passes through the point 0, 2. Now, if we use this previous technique, I'll put in 2 for y, 3 times 0 for x, plus b, but notice what happens is if I use the y-intercept, x is always 0, so I just get 2 equals b, and just like that, I know that y equals 3x plus 2. And so I can get it very quickly that way. Now, similarly, as the last video, you're probably going to be told these things as a general rule in real life. You're going to be told the slope and a point through English, and they're probably not going to call it a slope, and they're probably not going to say a given point, and you know, it would be more like, you know, you're observing a process, something like that, and you know, it could be, again, I'll use time because it's often the way we look at things, and I could say something like, you know, we make 500 bolts. You know, maybe I'm a manufacturer of bolts or something like that. We make 500 bolts per hour. Now, I'm sure that's actually way too low a number, but you know, we make 500 bolts per hour, and you know, and we have an inventory. Okay, an inventory of you know, maybe we'll go with 5,000 bolts at you know, 3 hours. Okay, now, so what does that mean? Well, you had some bolts to start with, but you just don't know how many, right? And because in 3 hours, I know that I could have only made 1,500 bolts. So 5,000, that's too many for that, you know. So I must have had some number to start with. But again, you see 500 bolts per hour. That looks like a rate of change. So I'm pretty sure that's m. And here is my point. Here is x, and here is y. And so I know that I have y equals 500x plus b, and so then I place these things in here, and I get 5,000 equals 500 times 3 plus b. That's 1,500. I'm going to subtract 1,500 from both sides, and I get that my b is equal to 3,500. So that day, or whatever that started, you know, whenever I started with that 3 hours, I already had 3,500 bolts in my inventory, and so I could then write this as y equals 500x plus 3500. And that would describe my bolt making process for today at this point. Okay, so again, you know, I'm told m and I'm given a point, but in real life we don't usually use those particular words. We're talking about a real life process, something like that, and so we have to translate. Okay, so it comes down to that idea of translating. And so now the one video we looked at, you know, what if you're given a slope in the y-intercept or the starting point, and this video then we're given the slope and some other point, but we can use this relationship that we know, since it's a straight line, we know that we have that relationship between our x and y. And so if I know any three of these quantities, if I know y, m, and x, I can tell you b. If I know y, m, and b, I can tell you x. If I know y, x, and b, I can tell you m. And if I know m, x, and b, I can tell you y. So you see, we've got this relationship. If I know any three of those quantities in that relationship, I can tell you the other part. Okay, so that does it for this video.